Hi everyone, and welcome to Maths Mastery Learning. Today we'll continue learning about fractions and we'll start with comparison of fractions. Essentially, we'll be comparing two fractions to determine which is greater. We could also extend it to compare three fractions and rank them in ascending or descending order. So let's begin with two fractions. And there are two cases here. A situation where the numerators are different and the denominators are equal. So if the denominators are equal, like in this example where you have 1 over 4 and 3 over 4, all you need to do is to compare the numerators. So we can see that the numerator 3 over 4 is greater than the numerator of 1 over 4. So obviously we can say 3 over 4 is greater than 1 over 4, right? We can also say that 7 over 8 is greater than 5 over 8 because they have common denominator and the numerator of this fraction is greater than the numerator of the second fraction. However, that is not the case if the denominators are different. So let's look at the second scenario. For example, we want to compare 3 over 4 and 5 over 8. Now, we cannot single-handedly pick out 5 over 8 as the greater fraction just because 5 is greater than 3 in terms of the numerator comparison and 8 is greater than 4 in terms of the denominator comparison. All we have to do here is to ensure that both fractions have the same denominators, right? So we're going to express these two fractions such that they both have common denominators. Now, how do we do that? This is a denominator of 4 and this is a denominator of 8. We are going to look for the lowest common multiple. That is the smallest number, the lowest number that can be divided by 4 and 8. There are a lot of numbers that can be divided by 4 and 8 at the same time, but we pick out the smallest number. So we can see here that 8 is the LCM. That is 8 can be divided by 4 and 8 can be divided by 8 at the same time without a remainder. So we need to express each of these fractions such that they have denominator of 8. So we have 3 over 4 and this is going to be equivalent to, for us to make this denominator of 8, we need to multiply both the numerator and denominator by 2. So this gives us 3 times 2 and 4 times 2, which is 6 over 8, right? Now, 5 over 8 already has a denominator of 8, right? We can leave it like that, or if we want to break it down, we just say 5 times 1 over 8 times 1, which is 5 over 8. Now we can compare these two fractions and determine which is greater, right? They both have common denominator now, and we can compare the numerator and see that 6 over 8 is greater than 5 over 8. But the fraction that leads us to the 6 over 8 is 3 over 4, right? And we're comparing with 5 over 8. Therefore, we can say that 3 over 4 is greater than 5 over 8. Okay, now let's compare three fractions and rank them in ascending order. We have, for example, 1 over 2, 2 over 3, and say 3 over 5, right? These fractions, we're not sure if they are in ascending order, but we want to attempt ranking them and arranging them in ascending order from the lowest to the highest. Okay, now, the first thing to do is to get the lowest common multiple, that's the smallest number that can be divided by 2, 3, and 5 at the same time without a remainder. So the sum of 2, 3, and 5 is 30, right? 30 can be divided by 2, 3, and 5 at the same time. Now, We're going to express each of these fractions as a denominator of 30. So we pick 1 over 2. To make 1 over 2 have a denominator of 30, we multiply both the numerator and the denominator by 15. So this will be 1 by 15, 2 by 15. This gives me 15 over 30. Now, let's pick out 2 over 3. We want to make it to have a denominator of 30. So multiply the numerator and denominator by 10. So this is going to give us 2 times 10 over 3 times 10, which is 20 over 30, right? And lastly, we pick 3 over 5 to express it such that to have a denominator of 30, we multiply both the numerator and the denominator by 6. So this will be 3 times 6 over 5 times 6. That will give us 18 over 30. Now, we can directly compare the numerators of these 3 fractions. We can see here that this is the greatest, followed by this. 20 over 30 is the greatest, followed by 18 over 30, and the least is 15 over 30, right? So we can rank this fraction in ascending order as from the smallest, that's 1 over 2. It's less than 3 over 5, and it's less than 2 over 3, right? Now, let's talk about addition of fractions. Addition of fractions. Now, there are 2 scenarios when we want to add 2 fractions or 2 or more fractions together. A situation where all of the fractions have the same denominator. For example, we have 3 over 4 plus 1 over 4. This can be added directly because they have common denominators of 4, right? You can just add the numerators together, 3 plus 1, everything over 4, right? This will give us 4 over 4, which is 1. Another example, maybe this is 1, this is 2. We have something like 3 over 8 plus 1 over 8, right? You can add the numerator directly and divide by the common denominator. So that's 3 plus 1, everything over 8, which is 4 over 8. And we can break this down further into, let's say, 4 into 4, 1, 4 into 8, 2. That's going to give us 1 over 2. Now, the same thing applies if we have more than 2 fractions. So we have something like this. Let's say 2 over 15 plus 5 over 15 plus 8 over 15. As long as the denominators are common, all you have to do is to sum up the numerators and divide by the common denominator, right? So this is going to give us 2 plus 5 plus 8, and that will be everything over 15, which is 2, 5, 7 plus 8 plus 15 over 15, which is 1. All right, let's consider a situation where the denominators are not common, where we can just easily sum up the numerators and divide by the common denominators as we saw earlier, right? In this case, we have 1 over 5 plus 3 over 4. Now, there are 2 approaches I will show you to solving this, right? The first approach is to cross multiply the numerator of the first fraction by the denominator of the second fraction, which is 1 times 4, plus the numerator of the second fraction times the denominator of the first fraction, which is 3 times 5. Everything divided by the product of the 2 denominators, which is 5 times 4. Right? So this will be 4 plus 3 times 5, 15 everything over 20, right? So this is 19 over 20. That's one approach. Now, another approach, let's call this method 1. Method 1, and let's call this method 2. We have 1 over 5 plus 3 over 4, right? We need to get the LCM of 5 and 4, which is 20, right? That 20, which is the LCM of 5 and 4, will form the denominator of our results. Okay, now how do we get the numerators? So use 20, divide by the first denominator, which is 4, times its numerator, which is still 4. So 20 divided by 5 is 4 times 1, which is 4, plus you do the same thing to the second fraction, which is 20 divided by 4, which is 5, times its numerator, which is 3. And that gives you 15, which is 19 over 20. So both gives you the same results, right? All right, now let's sum up fractions that are more than 2. So we have 1 over 2 plus 3 over 4 plus 1 over 8. This one you cannot easily cross multiply and use the method 1 that we used earlier on. All we need to do is to get the LCM of the denominator, which is LCM of 2, 4, 8, which is 8, because 8 can be divided by 2, 4, and 8 without the remainder, right? Now, this 8 will form the denominator of our result. Okay, so just like we did earlier, we are just extending it by another fraction. So now 8 divided by the denominator here, 2 is 4, and 4 times 1 is 4, plus 8 divided by 4, which is 2, times 3, that gives us 6, plus 8 divided by 8, it's 1, times 1, which is still 1. So this gives you 4, 6, and 1. Add them together, gives you 11 over 8. And this becomes an improper fraction, which we can actually express as a mixed number. So 8 can go into 11 once, but then there is a remainder of 3, which will form the numerator of the fractional part all over denominator, which is 8. So it's going to give us one whole number, 3 over 8. All right, now let's talk about subtraction of fractions. It's similar to addition of fractions, right? If the denominators are common, you just subtract the numerators and divide by the common denominator. So, for example, we have something like 7 over 13 minus 2 over 13. They have common denominator of 13. So, you just need to subtract the numerators, and that gives us 7 minus 2 everything over 13, which is 5 over 13, right? Now, if we have a situation where the denominators are not equal, right? For example, we have 2 over 3 minus 1 over 6. Okay, the denominators are not equal. So we could also do the cross multiplication and we can find the LCM, use the LCM approach. So let's use method 1. We cross multiply, we can say 2, the numerator of the first fraction, times the denominator of the second fraction, which is 2 times 6, minus the numerator of the second fraction, 1, times the denominator of the first fraction, which is 3, everything over the product of 3 and 6. And that gives us 12 minus 3 over 18. 12 minus 3 is 9 over 18. No, 9 over 18 can be simplified further. 9 here, 1, 9 here, 2, which is 1 over 2. Now, the second approach is to use the LCM. Now, the LCM of the denominator, LCM of 3 and 6 is 6, right? So 6 forms the denominator of our result. So 6 divided by 3, which is the denominator of the first fraction, gives you 2 times 2, which is the numerator, that gives you 4. So 6 divided by 3, 2 times 2, 4, minus 6 divided by 6 is 1 times the numerator, which is 1, that gives you 1. So it's 4 minus 3, it's 3 over 6. Right? 3 over 6 can be broken down further. 3 here, 1, 3 here, 2. And that also gives you the same result of 1 over 2. Right? The same approach, the same methods. Right? Alright, now let's talk about multiplication of fractions. Right? For example, we have 3 over 4 times 5 over 8. So, since none of these fractions is reducible to the lowest term, what we can do is to multiply the numerators together to form the numerator of a new fraction and multiply the denominator together to form the denominator of the new fraction. So we have 3 times 5 over 4 times 8. So 3 times 5 gives you 15, 4 times 8 gives you 32. So this fraction cannot be broken down further, and we'll just leave it like that, and that's the final answer. Now, there are other cases of multiplying fractions. For example, you have something like 4 over 7 times 14 over 20. Now, we can apply this same approach of just multiplying the numerators directly and then the denominator directly. But if you look closely, you will see that we can actually reduce this fraction diagonally, right? We can say 4 here 1, 4 into 20, 5, right? 7 here 1, 7 into 14 is 2. So we are left with 1 times 2 over 1 times 5. This is times, looks like it plus. So this is going to be 2 over 5, right? So we can actually reduce a fraction and cancel out numerator, denominator vertically or diagonally, so that we carry out our multiplication and arrive at our results, right? All right, now let's solve more examples on fractions. The question is, what fraction must be subtracted from the sum of two whole number 1 over 6 and two whole number 7 over 12 to give three whole number 1 over 4? And one out of these 4 options is correct. Now let's solve. We are given two fractions, two whole number 1 over 6 and two whole number 7 over 12. So the first approach is to sum the fractions together. This will give us a result minus a certain fraction, let's call it x over y, and that should give us 3 whole number 1 over 4, right? These are all mixed numbers, whole part and fractional parts. The first thing to do is to convert them to improper fractions, right? So 6 times 2 gives us 12 plus 1, the 13 over 6, plus 12 times 2 is 24, plus 7, which is 31 over 12, minus unknown fraction. So converting this to improper fraction gives us 4 times 3, 12 plus 1, 13 over 4. Now, the LCM of 6 and 12, let's perform this addition. 12 divided by 6 is 2, 2 times 13 is 26. 12 by 12 is 1, times 31 is 31, minus x over y equals 13 over 4, right? Now, 26 and 31 gives us 57 over 12 minus x over y equals 13 over 4. Now, this 57 over 12 is the result of adding these two fractions. And the question says, what fraction must be subtracted from that result, which is x over y, to give 13 over 4. Right now, let's collect the like terms together. 13 over 4 crosses over to the left-hand side, it becomes minus 13 over 4, and then x over y crosses to the right-hand side, becomes positive, which is x over y. Right? Now, let's perform this subtraction. This gives us 12 divided by 12. 1 times 57 is 57. Minus 12 divided by 4 is 3 times 13 gives us 39, equal to x over y. This implies that 57 minus 39 gives us 18. So x over y is equal to 18 over 12. Now, this fraction can be broken further, right? 2 can go into both the numerator and the denominator. 3 can also go. 4 cannot. 6 can go. So let's go with 6, which is the highest number that can divide both the numerator and the denominator. So 6 here 3 and 6 here 2. This implies that x over y is equal to 3 over 2. Now, converting it back to a mixed number, 2 can go into 3 once, remainder 1 over 2. So 1 whole number 1 over 2 is the fraction that must be subtracted from the sum of 2 whole number 1 over 6 and 2 whole number 7 over 12 to give us 3 whole number 1 over 4. So the correct answer is option D. Alright, so as a concluding part of today's class, I'll be leaving you with a few exercises to try. Feel free to post your answers in the comment and let me know if you encounter any challenges and need more explanations. See you next time. Now let's talk about division of fractions. We are given 3 over 4 divided by 2 over 5. Now the approach is this. We'll pick the 3 over 4, which is the first fraction, and multiply by the reciprocal of the second fraction. So we are basically inverting. Since we are changing this division to multiplication, we'll invert this fraction to 5 over 2 instead of 2 over 5, right? And then perform the multiplication as before. So we cannot cancel out anything here. That leaves us with 3 times 5 over 4 times 2, which is 15 over 8. And this becomes an improper fraction. Can convert it to a mixed number to have a whole part and a fractional part. So 8 can go into 15 once. That's one whole number. The remainder is 7, which forms the numerator of the fractional part. Everything divided by 8. Okay, let's pick one more example. Let's say we are trying to divide 5 over 7 divided by 1 over 2, then divide by, say, 8 over 21, for example. Okay, all you need to do, just like the above example, is say 5 over 7 times, you take the reciprocal of this fraction, you invert it, that's 2 over 1. Again, this operation gives you one result, but since it involves another fraction, you just invert this fraction as well to give it 21 over 8, right? So what can cancel out here? 7 here 1, 7 to 21 is 3. 2 here 1, 2 into 8 is 4. Okay, so nothing cancel out again. We have 5 times 1 times 3, which is 15. Divide by 1 times 1 times 4, which is 4. And that gives you 4 into 15, 3 times, because 3 times 4 is 12. You are left with a remainder of 3, everything over 4. So we have 3 whole number, 3 over 4. That's our final answer.